Cool. So start off like I always do. I open terminal. In the bottom right here, I have my test code folder. It's already in, but I'll. Oh, can you guys see the screen? Anyone? Can you guys see my screen?
Yes.
Cool. So I open up, and I've got my day 5. As a recap, we'll go over what we did last time, because last time was pretty advanced. We're just going to keep building on that, but with a different example. So for day 4, we kept using objects and kept using functions, right? Except we added different types of properties to the objects here. We learned how to model something, like a message should have specific fields and a user should have properties, and a user should have specific properties. And we can rely on those when we pass them into functions using .text, .kex, .user. And if you did the bonus, you did a nested object, an object as a property on another object. We also added arrays. So arrays were a property on an object. So all that is to say is anything can be a property on another object. Any type can be a project on another type. String, Boolean, integer, array, objects. So today we're only adding one thing. We're adding functions as types to objects. You have already been doing this, again, without knowing it. It's kind of the theme, is I'm making you do something and revealing what we're doing after. We know that dot notation is when you're calling on an object or an array. So console.log is already a function on an object. The object is console. The function is log. Console.log. You might have noticed that all of your other functions so far just look like function, my function, and then I call my function, right? There's no dots necessary because those functions are declared standalone. But console.log is already, console is the object, log is the function. So if we were going to define our own, if I said like this, it would look like this. Declare an object of type console, of name console, and add a log property. But instead of making this, hello, or an array, or a number, make it a function. So that's what this looks like under the hood. They have a bunch of code in here, that prints something to your terminal. But this is what that is. Console is the object. Log is the function. And you can see if I hover over these built-in functions, I get a lot of information about them. Probably too much information for new people, but at the very least, it's helpful to know you can kind of hover over and see that. If I right-click, which is something we're going to be getting more used to, right-clicking something gives me a lot of information about it. Oops, didn't mean to click that yet. I can right-click and I can go to the definition, which is, when you define or declare a function. I can go see what it looks like in the source code. This is like the actual JavaScript built-in code. If I right-click the console, I can see they declare a console variable. So we're just using a built-in object that is a built-in function. And it looks like this when you define it. We don't want to overwrite console, so I'll comment that out because we already have a console. But what's a use case for a function on a object? Discontinuing with the Discord message idea, because I feel like we should start over with a new idea to reinforce, different user model types, is let's make a game. Let's think about our game. Let's get the idea of thinking about what we're doing before we do it now, rather than just defining some arbitrary Discord message. Before, we didn't really need to think about it because, we know how Discord works. We've been modeling Discord. All this stuff makes sense. But let's begin thinking about our stuff. Our game should have a character. Should have the ability to create a character. A character can have attack or it can have magic. A character can have health. Must have health. A character must have a level, and the character must be able to level up, increasing its attack or magic. So let's capitalize this as well. So you might notice I put emphasis on can and must here, right? If we go back to day 4 quickly, and we think about those can and musts in terms of those messages we made. If we were going to describe those in the same way, we'd say, well, a message must have a name. We need to rely on that. It must have a user is where we went to later. It must have a user right here. It must have kex, and it must have text. We need those things. It must have them. If we think of a user, we said it must have a name. It must have an isAdmin to determine whether it's an admin or not. Must have an isYellow. And then the homework, which isn't included here, was it must have roles. Roles can be empty, but it must have them. When you defined that function, you had to do this. If everyone did the homework, you gave it the empty array of roles. It must have roles. Roles can be empty, but it must have them. Leaving it off like this was not an option for that object model, right? It must have them. So if we think about that, must have health, must have a level, must be able to level up. So let's create an example. Let's say my mage is going to have health, must have health. Okay, has 100 health. Must have a level 1. Oops, level. Okay. Now, it must be able to level up, increase against attack or magic. Sounds like we need a prerequisite of being able to have attack or magic to do that. So let's go here. A character can have attack or it can have magic. So let's say my mage has magic damage. Deals 10. Deals 10 magic damage when it attacks. Let's define my warrior. Has health. It's got more health, got 150. Level is 5. And it's got attack damage because it's a warrior, doesn't have magic. And deals 7. So we're already noticing a difference between our characters. One has magic damage, one has attack damage. Different property names. We know from our previous day that everything had the same property name. How do we deal with this? If I have a function called fight, and it takes character 1, right? First character, and who's he going to fight against? I can't use character 1 dot attack damage without knowing if it has attack damage or magic damage. Similarly, I cannot use character 1 dot magic damage because they don't all have this. It's not reliable anymore. Our contract is broken. That model contract that we have is broken. There's nothing I can do here with what I have to make sure that I could really have this really convoluted, okay, if character 1 dot attack damage, now I have a warrior, now I have a guy with attack damage, else, blah, 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 dealing with it that way in this function. But like that's messy and bad. It doesn't work. It doesn't scale. What if we have a character can attack, or it can have magic, or it can use a skill, right? we'd have to have another thing in that if statement in the fight, because we can't rely on the names of these properties anymore. Our contract is broken. But what if our contract also involves functions, that model, that object model? A character must be able to get its attack or magic damage reliably between instances of the objects. We can do that with a function. We can say, let's call it get damage. And it's a function. And my warrior will have a get damage, and that's a function. And now when they fight, I can say const character 1 damage is equal to character 1 dot get damage. Const character 2 damage. Character 2 damage is equal to character 2 dot get damage. So if I call fight with, my mage and my warrior, both of these things, my mage and my warrior, character 1 and character 2 to the name of this fight, they both have this get damage function. Now I can rely on this, right? Again, we've made a contract between the programmer and the objects here and said, well, we can't rely on individual properties here. There could be a million different variables that determine how much damage you do. You might have a buff, right? An array of buffs for your character, like positive things, right? +1 damage you want to add to it. We're not going to implement that now, but they might have that as well. So even if they have the same name or property of attack damage and magic damage, it doesn't take into account the buffs. You might have curses on you that give -1 damage that we need to factor in. It would get very messy to account for this elsewhere. Each character should be responsible for calculating its own damage. So how do we get access to the damage in the function? Because right now, if I run this and I console.log the character 1 damage, and I console.log the character 2 damage, and I run it with node day5.js, I get undefined because our functions don't do anything, right? We didn't do anything in the function. But we can see that they actually both did call, though, so that's good. Character 1 has get damage, character 2 has get damage. It's pretty sweet. So now we're going to learn about one of the most important things about objects is if I was down here in between these two things, I think we know by now I could do console.log mymage.magic damage, right? Because I'm outside of the object. I've declared the object. It's called my mage. It has a magic damage property. The value is 10. Hi, console.log mymage.magic damage. We've done a lot of that stuff already. We'll be doing a lot more. But that works. But I can't do that in this function because my mage doesn't exist yet. I'm still creating it. It's part of the declaration of it, right? My mage only exists after this block is run. So if you ever want to access a property of an object while you're in the object, which is going to be a concept we're going to be working a lot with, you use the keyword this. Just like const function, we have another keyword. Just like for and if, it's this. You can see that if I type this, and if I type dot, I get access to all the properties up here of my guy. Get damage, health, level, magic damage. So we'll go over that again. I'm in my function in an object. Sorry, on an object. And I need this get damage function to somehow return this magic damage property. That's the goal here. So I can say return, because I know we need to return, not console log, because I need to return this dot magic damage. And for the warrior down here, this guy has this attack damage property. So I can say return this dot attack damage. And down here in my fight function, whatever characters I pass in here, right now, a mage and a warrior, I call the get damage function on that character. So if I run this, I get 10 and 7. So these magic damage and attack damage are no longer part of our object contract. That's why we say can here. A character can have attack or it can have magic. But if it must be able to get its attack or magic damage reliably between instances of the objects, you'll kind of come into this situation quite a bit. And, you know, this is one of the more complicated things that I think new people struggle with is, you know, you learn a couple of things. You learn arrays, you learn objects, strings, booleans. You're barely able to complete the exercises with the given keywords. And then all of a sudden you need to like kind of step up the logic a little bit where you're combining them. We're combining an object, which has a property named get damage, which is a function, which returns another property on the object. It's going to be a little bit overwhelming at first. But this is pretty much the only thing I'm going to teach today, and we're going to have quite a bit of homework on it. So I'm going to go over it again with another thing, because we're missing one. We're missing a character must be able to level up, increasing its attack or damage, magic. If I was going to create a level up property, I would start with the level up, name it level up. But it can't just be like a number. It can't just be like a string or another object. This also has to be a function because we need to increase this number, right? We're leveling up. And we also want to increase this number. We're giving it additional stats. Maybe we add health to it. So it needs to be a function as well. We want to change those. And it's going to be different for every character because you wouldn't want to give your warrior spell damage. It doesn't do it. So this is another instance of a function as a property. And you've noticed kind of maybe, and some people commented on this before, what do the colors mean? Yellow indicates it's a function. You can see that here as well. When you declare your function, it's yellow. When you call .log, it's yellow. The function part is yellow. That's your takeaway. You're dealing with a function when using VS Code. Get damage is the function. This is the variable, which is an object. Same with console. This is the function. So we can see we have a new function here, level up. So I can say, again, this, which refers to this object, that's the magic here, right? The real magic of using a function on an object is that you get this out of it. You get to use this. And I can change stuff on the object by calling the function. So this dot level, we probably want to add 1 to it, right? We're leveling up. This dot level is equal to this dot level plus 1. So if I call my mage dot level up, my console.log, my mage, let's see what happens. Oh, my level is 2. You can see that it stays 2 even after I rerun it. Because every time you run this script, it starts from the top again, right? It doesn't persist. We're not saving this to a file or database or something. So leveling up is only for the instance of that one time you run node. I know nobody's asked about that yet, but typically that's an early question is like, why isn't this stuff persisting? It's because we're not saving it to a file. So every time you call dot level up, or anytime you do any of this, it all redeclares. So my level is going to be 2. So I can call it again. Level up. My mage dot level up. Now you can see that my level is 4 after I've leveled up 3 times. Maybe we all want to give him more magic damage as well. So I can say this dot magic damage is equal to this dot magic damage, get the base value, and then add 3. Every time I level up, I get 3 more magic damage. So if I log them out, I can see I get 19. And if I put the console logs in between, I will make this easier to read down here. We can see him start off with 1 level up, and then we log. So level up and log. Hey, this dot level is incremented. This dot magic damage is incremented. Great. But if I console.log my warrior, here, I'll actually do this, console.log my warrior, and we'll make his base level 1 for ease of reading. So now we can see everything below the string my warrior is going to be my warrior. You can see he's still level 1. This guy didn't level up because he's not part of this for my mage. This refers to the my mage object only. Even if I take this and I copy it and I paste it and I say my second mage, everything's identical, right? I just copy and paste it. It's the same thing, but I change the name. We can level up my mage the 3 times, in console.log my second mage, and then console.log the actual mage. I'm just putting those logs in strings to make the logs readable. So when I see the string down here, I know what I'm reading. So I scroll up till I see, there we go, my second mage. My second mage is still level 1, even though my first mage is level 4. Because this is a completely different object. Even though it's identical, there's nothing wrong with having identical things. Whenever you create a mage in World of Warcraft, you're at the screen, you click create mage. It creates you a new level 1 mage, and it's identical to any other one. And then you can create another level 1 mage right away. Nothing's stopping you. You have 2 level 1 mages. But when your first mage levels up, it can't level up the second mage. That's not how games work. So we can have 2 identical objects. That's fine. But it's only going to level up the one because this only refers to the actual object this is referring to. This, my mage. This, my second mage. If I want to level up my second mage, I need to go console.log my second mage.level up. Oops, not console.log my second mage, just my second mage.level up. We don't want to console log. Now we want to console log my second mage again. You can scroll up till I get to my second mage, and you can see it starts off level 1, and now it's level 2. And it's got more magic damage too. So this only refers to the object that it's relevant to. This, my mage. When you call level up, it can only refer to my mage. My second mage and my warrior are undone. So we know we need to implement the level up function on my warrior still. So I can say level up function and not return. We want to this dot level is equal to this dot level plus 1. This dot attack damage is equal to this dot attack damage plus we'll give them 2. So now we can call my warrior dot level up and console.log my warrior. Boom. We can see here my warrior is level 1, attack damage 7, level 2, attack damage 9. This is actually how games work. The code will be more organized. There will be a lot more higher level stuff going on. They will be in separate files to not make one big confusing file. But this is how they work. If you get good at this stuff and you understand it, you can do this over and over and over and over and over. This is truly one of the last like built-in language construct things we'll learn. It's mostly just combining all this shit from now on. Now that we have an object and we can access properties on the object from a function on the object, the possibilities are really, limitless. It's very useful stuff. I can whip up a quick example of like completely different example, and you guys can just watch it happen. And be like, I've got a sword, and it's got is sharp true, and I've got a function. I've got a stab function. Now I say if this dot is sharp, this dot is sharp is equal to false. It's no longer sharp. And I can say console.log stabbed. But if it's not sharp, which is the else statement, I can say console.log can't stab with a dull knife. So the first time I use stab, it should work. But then the sharp will be, then the sword won't be sharp anymore. And I can't stab. So if I say sword.stab and I run it, see the bottom, I got stabbed. Let's try it again. Sword.stab right afterwards. Oops, forgot to save. Teehee. And I get can't stab with a dull knife. This kind of control over an object with the function is so useful, and you can use it for a million different things. You can model out anything with it, really. And you can change properties in the middle of a function. It's very useful stuff. If I go back to the Discord model and I say const user is equal to name, Horsey, roles, team, and then can delete Discord. Or sorry, we'll call this delete Discord. And it's a function. Because only team can delete. So I need to write code here that looks over my user's roles and determines whether team is in there. And if it is, I can delete. Otherwise, I can't delete the Discord. So within this function block, I can write anything. The reason I'm doing all these subsequent examples is kind of give you guys more of a viewpoint. Up here, we have accessing this as dot level as a number. Here's this dot attack damage as a number. We've really used this function cleverly, I think, because we have magic and attack damage on two different characters. Here we have attack damage. Here we have magic damage. So now with this get damage function, that's really clever. We don't care about the naming of those properties. We can implement so many different classes besides mages and stuff, and we can implement buffs, and we can do all this kind of stuff. And all that logic can just be in our get damage function. Maybe you have a temporary curse that reduces your damage by 100%. And if you have that curse on you, then you return 0 damage. Maybe you have to check whether the target is a ice monster. And if you have a fire sword, then you deal more damage. You deal bonus damage. There's so many things that you can do here. And that's literally how game programming works. But these examples are quite simple. This one is a little bit more complicated. An if statement within the stab function that checks the is sharp property on the sword. And then we have the object sword we call stab on it. Now, if I want to delete the Discord, I kind of need to loop over my roles. So I can write a loop in here. I can say for let I is equal to 0, I is less than this dot roles dot length I plus plus. We're combining some stuff from several days now, which is going to be the goal. We're now doing for loops within a function on an object. And it shows how powerful it is. We don't even need a separate function to do this. We can just say right around. I can loop over this guy's roles right on the object. And I can say this role is equal to role. Sorry. This dot roles I. Forget. This will be equal. Every loop const role is equal to an individual string role. So I can say if role is equal to team, return true. Else, continue. So this is something that just lets the loop continue. We don't want to do anything. If we found the team, the role team in the loop, we return immediately. We return true, which stops the loop. We don't need the loop to continue anymore. We found the role that lets us delete. Otherwise, we continue. And if this loop runs and we have not team, GMI, Crane Manager, Dipley's Fan Club, it'll run 4 times, 1, 2, 3, 4 in the array, and never return true. And actually, let's call this can delete Discord because it returns a Boolean. This function returns a true or false. Can you delete the Discord? So now, I know some of you guys did this. I saw some people screwing around and making this kind of thing, trying to delete messages and stuff after the bonus example from yesterday. So if you didn't screw around or see people screwing around, they kind of were like, oh, what if someone could delete messages in the Discord? Just like that works, right? Well, here it's the same thing. We're going to try and delete the Discord. But we can say if user dot can delete Discord, delete the Discord. Else, user can't delete the Discord. So each user, each user can check itself so that my function to actually delete the Discord doesn't need to do all of this in there. That logic doesn't belong there. I'm just trying to delete the Discord. I shouldn't convolute it with a lot of stuff. So I check it on my user object. I have a dot and then a function. If the user can delete the Discord, so if it returns true, I need to then write my code to actually delete Discord in here. I can delete the server. Otherwise, I can't. So those are 3 kind of different use cases for functions on objects. And it shows that anything can go within the function scope. It's not just, it's not like you can only write for loop somewhere and you can only write if statements somewhere and you can only write numbers and strings elsewhere. It's just a regular function within this function block. It's the only difference is instead of doing it like this and naming it like this, we put it up here. And this is easier because here we'd actually need to pass in the sword as an argument, right? And instead of that, we'd have to say if sword dot is sharp and sword dot is sharp there, because we can't access this. It's just a random function. There's no difference between this and this. The name is over here for this function, right? Over here, it's here. And this one takes no arguments because it can access this. This one takes a single argument, sort, because it's like every other function we wrote. To be able to access something, you need to pass it in. It's a sort. To call this one, we would have to do, like we've traditionally done, right? The function is named stab, and it takes a sort. So we pass the sort in. Here we get to call sort.stab. It's a little bit cleaner. And of course, it also lets us access all these cool properties using this directly. It's the same thing for if a user can delete a Discord or not. This is the same thing as this. I can just paste the whole function, get rid of the syntax difference, but pass in the user. Over here, the name of the function is over here, object property, and it's a function. And we don't need to pass anything in because we can access this very clean. Here, the name of the function is here instead, like all the other ones we've seen. And we have to pass in a user. And of course, we can't access this. Here's a user.roles. The main difference between these two things and these two things, I don't know if anyone's picked up on it because it's a lot today, but the main difference is when it's defined as a function on the object, every object can act differently, right? If we scroll up to the mage, we go to the mage, we take the warrior, take the mage here, get damage returns magic damage, and here, get damage returns attack damage. Let's try and do what we did down there. Let's take this, the get damage function, we're going to take it off the object, and we're going to say, okay, function get damage, and it takes a character because, we don't have access to this anymore, so we have to pass it in. Over here, can access this. Okay, so, we need to return character.attack damage, right? We've done a lot of this kind of stuff. But now we see this doesn't work for all characters because this mage doesn't have attack damage, it has magic damage. So now we actually have to do something stupid if we do it off of the object themselves. We have to say, okay, if character.attack damage, return character.attack damage, else return character.magic damage. Whereas before, we can keep these one-liners. It's very small. This one only has attack damage, and it knows about it. And it can be different than any other any other object's get damage function. It just needs to do its own calculations and return what's relevant for this object here. Same with the mage. It doesn't have to worry about attack damage. Very clean. Much easier to not write bugs like this. In a world where we have const my thief, and he has health 100, level 1, he has speed damage 50. He's strong. So now we say get damage is the name of the property. It's a function. And we return this.speed damage. Dope. Again, this guy doesn't need to worry about attack damage. He doesn't need to worry about magic damage. He just worries about speed damage. But now, if I was going to do it the other way, where, we have the function here, we just say get damage, we pass in a character. That's the way we've been doing it traditionally, right? Now I actually need to say, okay, this doesn't work because now I have to account for speed damage in here as well. Fuck. So that's an if here, else if character dot magic damage, return character dot magic damage, else if character dot speed damage, return character dot speed damage. This function, as you make a real game, you know what I mean, would be crazy. It would be insane. It would have, if you're playing WoW, it would have 12 classes, hundreds of buffs, 100 of curses, equipment to factor in, all within one function to return damage. It would probably be, 10,000 lines long. It would be the most buggy mess you've ever seen in your life. It'd be impossible. But it's so much easier to keep defining new objects like this, and they implement it themselves. They all need one line. It's so much cleaner. I mean, I hope you guys agree that it's so much cleaner to have smaller, more encapsulated functions like this than it is to have one very large, big function that does all the checking itself. And to make it clear, we don't need this function. This is a duplication of the separate implementations of the get damage function. It's just a different way to do it. That's the way we have been doing it. We've been saying everything is a top level function. Nothing's on an object. Nothing's a property. Oh, top level means when it's not in anything, by the way. So like, we declare the functions out here. We just say function fight, function get damage. It's top level. It's not on a property of anything. You can also see with console.log, if this wasn't on the console object and it was just called like log, you'd probably have to pass in a bunch of stuff console needs to work. But now you can just call console.log. And it has its own internal implementation of how to log something. You could make your own. Maybe you want when stuff logs, you want it to be red. You could write your own log, your own object, and your own log interpretation of that method. Change the text to red or something. Do whatever you want. Or prefix every line with something. But they wrote and encapsulated their own log thing on the object here. And we do that now as well. We say, yeah, every object is responsible for getting its own damage. And you can do the same with defense as we make this very, very complicated and the game becomes real. We say, okay, everyone's got defense 5. This guy's got the second mage. Actually, he's different. He only has magic defense. Sounds like I need a get defense method. Sorry, function to. Whoops. Need to get defense function. Return. For this one, I have the defense property here, so I'll return this .defense. And for this guy, I need to get defense property. And I have, I have magic defense. So I'll return this .magic defense. Now if I go down to my warrior as well, he's got defense as well. Got 5. Okay, I need to get defense and a function. Return this .defense. Cool. So all these guys have the same thing we did with damage. They're doing it with defense. Now if I go to my fight function, I can do the same thing. I can say const character 1 damage. Defense. Do character 1 .defense. No. Get defense. I can log it. Character 1 defense. And of course, character 2 defense is equal to character 2 .get defense. And if I comment this stuff out so that I only get the bottom log that I want when I call fight here, because I'm passing in my mage and my warrior. Oops, and I want console.log my character to defense. Yeah, 5 and 5 because I've set them to the same, which is a bad example. So if I go to my first guy and I set it to 6,000, he's like the toughest mage in the world. He's got cracked defense, dude. He's fucking pimp. Yeah, 6,005. And again, they're one-liners. I didn't need to, and they have different properties too. Like this one's using defense, and this one's using magic defense. And if my mage now fights my second mage here instead, the warrior's no longer in the equation. We see I get 3 instead of 5. This function gets to rely on the get damage property, which is dope. So that's pretty much it for the day. I will paste this in, and we're going to be doing a bunch of that stuff going forward. I apologize for how confusing this probably is. This is one of the biggest logical leaps to take so far, combining a lot of different stuff. But as you just like everything else, as you begin to type it and do it yourself, it makes more sense. Anyone got any questions before I stop recording and upload shit?
Yeah, is there like a list of somewhere that gives you like every, when you got to type something in to kind of like say this is what I want this to do? Is there a list of like predetermined like actual like functions that I could like look up somewhere that you know of?
What do you mean predetermined ones? Do you mean like console.log, ones that are built in?
Yeah, but like built-in functions or built-in objects or whatever.
Yes, yeah. There is a list. I'll link it.
All right, cool.
There's quite a few. You might not. The list might not be super useful, but it would help to just look over to get an idea of how much stuff is in a language built in.
Yeah, because sometimes I get confused. I'll look at something like, okay, is this something I got to like type in here, or is this something that's already there? Because like I know character 1 and character 2 you would have to define, but still like other things like that, it's kind of like, well, do I have to type, configure this myself, or does it already exist?
Yeah, for sure. I think that's the fun thing about that is the more you do it, the more you use the same built-ins, and you'll be able to look at code by and just know automatically what's built in. Because you kind of just do the same, maybe 20 built-ins all the time, like this, return, function, const,
Push. Like, what the fuck? The push thing threw me off.
Yeah, so push is basically the same thing as well. Push is a method on an array. Arrays.
So what is this then?
Sorry, this is referring to whatever you're doing, whatever object you're in.
Okay.
So I'm in an object.
So it's not.
So go ahead.
So it's not the same as push. So yeah, sorry to cut you off, but I'm trying to figure out what's the difference between this.
It's called the same as push, but internally, what it looks like is.
I was really hoping you were gonna just type out push these notes.
No. So what it looks like is this. So you see here, I've defined an object named array. It has
that's just confused the hell out of me.
Yeah, so I'll call this my array. But what I'm trying to do is show you what array is doing under the hood, because it's the same thing as we just did. So they basically created, JavaScript themselves have created an object that is an array and have a push method on it. All arrays are objects under the hood.
So it's just shortened it for you for a cleaner way of doing it.
Yes. So I could, if I was going to do this as well, I'm going to all right, function my bad push implementation. And it takes an array.
So they built JavaScript off of JavaScript? Like what?
Yes.
Wow.
Yes.
So it's just this never-ending thing.
Yes. Most languages are actually built in the language that they are as well. It's very confusing. I truly don't understand it as well. I've never gotten that deep far. That's very low level. But
Right.
if I was going to say I was going to write a push, but push is not a method, but I need to do it. Like dot push adds an element to an array. I need to do that, right? Like, but I don't have push. Say JavaScript where like we will pretend dot push on an array does not exist. How do we add something to an array? We still need to do it, but JavaScript devs in this world did not add dot push for us. Okay, so I have an array being passed in, and I'll say, hello, horse. So it's an array of 2 strings, and I call my bad push implementation, my array. So to add something to an array here, if I was going to remake push from scratch without having it, I would say, first off, I'd have to loop over the array. I is equal to 0. I is less than the array dot length. I plus plus. Okay. So now I need to determine whether I'm at the end of the array in the last element, because that's where I want to add something. So I could say if I is equal to the array dot length. Oh my God, -1. Because arrays are 0 indexed. See how complicated this is getting? So then I would have to say, okay, now I can set array of I equal to, oops, I need to put this thing I want to add is equal to thing I want to add. So I need to loop through the array if I'm at the end of the array, and I need to -1 from it because arrays are 0 indexed, but the length is not. If the length is 1, I only have a single element in the array, the 0th, right? Array length, not 0 indexed. Arrays, 0 indexed. Very confusing. So now this is what push looks like under the hood. But
okay.
JavaScript devs are like, who the fuck wants to write that every time? That's insane.
Yeah.
So
okay.
They do this for you and put it on the array, and they call that method .push. So they're like, okay, you know what? Arrays are objects, and it has a push method. And actually, what we can do is undo this. Sorry, and I'll grab this. Boing. Okay, so yeah, we'll say const arrays are objects under the hood, and it has push, which is a function, and it does this. And we say this dot length because we're in the object, right? This.
Yeah.
And then now we can call array dot push with the new item. And we never need to see this complicated, over verbose, what the hell is it doing code. That's the example of like built-ins, right? It's the same kind of thing. It's the same thing as like console.log. Like imagine if there was no console.log and it takes probably 20 lines of ugly code to print something to the terminal. So if there was no console.log, the first thing I would have taught you guys to program is how to print something to a terminal. And like,
God,
it would be so crazy. And you have to learn about inputs and outputs and how file syncing and all this kind of shit. But no, they're like, that's insane. You need to be able to log something to a console to use this language. We're not expecting every user to do that, right? So they're like, we're going to give you that. And arrays have way more than .push on them, by the way. They have probably 30 different functions on them that are very for your utility. Because you'll need to do a lot of stuff with arrays. You'll need to delete stuff from them. You need to reorder them. Maybe you want to sort them from like alphabetical or sort them by number or like arrange them or something. Lots of arrays. And they don't want, it's a waste of time for everyone to do that all the time. So arrays have a lot of dot functions on them. And we'll be using a lot of them going forward. And they're all just built-ins.
Horsey.
Yep.
Why is console.log not the last thing to make it return? Why do you have to type the following thing after console.log?
Where's that?
No, I'm just saying in general, like, why isn't console.log when you type that at the end why isn't that what you're printing?
It is. What do you, I don't understand the question. Is console.log the only thing it does is print?
No.
I think I
Like,
know what he means. You're telling it, I want to know this.
yeah, but then after console.log, you still have to type the name of your function. I don't think I'm right using the right terminology, but
Yeah, because that's what you want it to tell you. You want it to log, like, hey, what did this do?
Are you kind of like, what's the difference between like return and console.log?
no. It's hard to explain. I'll ask you in DM.
Oh, don't ask in DM. Ask in the code class general because it'll help explain stuff for other people.
Give me a quick.
What?
Yes. That why is it exactly Yahoo?
I didn't hear what he said. Hello?
Yeah, because console.log is you asking it to print what you've just typed as a function, but then you still have to say log username from message and then parentheses Dipley's message. Why is it not console log before?
Is my internet cutting out or are you cutting out?
I don't know. Yahoo answered my
No, it was
question.
fine for me.
Okay, my internet must be cutting out. You're cutting it. Can you repeat it one more time?
Okay, so when, like, for instance, when I've written console.log, right, and I'm printing the prior dot function, but after that I use a yellow syntax saying log username from message, and then in parentheses it says it. Why do I have to add that secondary thing?
I think I need an example. Do you mean you have a function like this, like my function, and then you're calling
Console.log isn't just logging the stuff above. It needs something in there. I think
Yeah, you're asking it what you want it to log. So, like, if you want it to say, like, the messages from Dipley, you want to tell it that you want to log the messages from Dipley. You know what I mean?
So is the yellow and then the thing in parentheses my declaration?
No, your declaration is this. This is
right.
This is called calling it.
Okay. So but why isn't
if that function returns 5, when I call it, the value of this block, the value of it, I'm calling this function, but the value of it is 5. So I need to tell console.log, I want to log the result of this. Whatever this returns,
okay.
I want to log it.
Okay. All right.
The interesting thing is, obviously, you need to return something. If I don't return anything, if I just say const number is equal to 5, and I run it, see, I get undefined. Because it doesn't return anything.
That's why I was struggling then, because I need to, it's like, I don't know how to say it. It feels like I'm going, it's backwards. You know what I mean?
Well, it kind of is backwards, because you kind of read this, some people read left to right and some people read right to left with programming.
Yeah.
Like, I usually read, honestly, right to left, because the thing on the farthest right is actually the first thing being run.
That's what I mean. I don't mean backwards as in retarded. Yeah, I mean, it's like, yeah, you get it.
Yeah.
Okay.
Totally. So whatever executes in here will run first, and this is called my function, and it runs and it returns 5. So now this may as well say 5. And then now it moves to the left and it goes, okay, console.log on 5. And you'll get to the point where you'll have like multiple functions, which is very weird as well. You'll have like 5 things like this, and it'll be very confusing to read. And that's how you know you've written bad code, is when you have like my function that calls my function that calls, pretend these are all different functions, right? And you'll end up in hell with code that looks like this. And it's how you know that you need to like refactor your code, because this is already, a function being passed into another function. You're calling my function into log, but you can truly chain it forever if this thing takes another function. And then now you need...
And that's why you're showing us early then. So...
Yeah.
You like trimmed it way down in the... the video game code you were writing.
Exactly, because like that code is unmaintainable. This example here, the get damage function that just gets damages based on a character you pass in, is like fucking crazy to maintain. Like every time you make a new character that has a different type of damage or a new buff or a new curse that can lower damage or something, you have to change this function. And that seems crazy to me. It's so easy to use a bug like that. Or maybe your game doesn't have buffs, and then you add buffs to the game later. And now this function needs to take in buffs as an argument. And now it needs to check the buffs. So I need to be like, okay, check the buffs array to see if they have plus or minus damage buffs, then apply it. And I've got to add all that stuff in. And that's going to be crazy. And like eventually you're going to look at this function and it'll be like longer than a page. It'll be like this. And you'll have to scroll up and down within it and be like, what the fuck does this do, man? Like, what the hell does it do? And usually when people teach coding, they start off with very big functions. And I'm trying to keep them like teach good programming examples early on so that we don't even need to like unlearn those things. It's easier to learn the more complicated examples of functions on objects and stuff, because that's really how people will do it. Nobody's going to write this gigantic function that can take in 1 million variables and then calculate the damage based on all of that. No one's going to do that stuff. That's how, like, if you ever play a game that's super buggy, it's because the code looks like this. Like, and it becomes huge and it's crazy and gigantic if statements and functions chained together. Like, if you ever play a game that is buggy as hell, they have this code. They have bad code. If you play a game that is not buggy, it's good code. It's very good code. Sometimes like they'll push an update to a game and it introduces a bug, right? Like it happens all the time. I think Elden Ring just did that today. They're like you can crouch poke in Elden Ring with weapons you're not supposed to be able to as of a patch today. And it's probably because they have a big ass function like this. And it's called like function can crouch poke. And it takes in the weapon as an argument. And it goes like if weapon is equal to polearm, return true. Else if weapon is equal to staff, return false. It can't. And then else if weapon is equal to a bow, return false. It can't. Bows can't crouch poke. They probably have a big ass function like this. And then they added a new weapon and didn't put it in that function.
And now it's just broken.
Yeah, now it's just fucking broken because it's not even in here. So it's not going to return false or true. But if they added it on the weapon instead, and they say, okay, we got a new weapon, and it's here's my new weapon today. Yeah, it's a type is a pole arm, and can crouch poke is a function, and it returns true. Pole arms can crouch poke. Like now, there is no big function update. Only when you created the new weapon did you worry about this, and then it was done forever. It's like way harder to fuck up. You don't need to like add something and be like, fuck, where is that used again? Like, oh man, I need to like everywhere a weapon is used in the code, we got to go look and see if I need to add new shit because it's new weapon type. When you see a game that can add stuff really quickly and they can update really quickly, it's because they're using this kind of coding practice. It's so easy. They can just like make the assets in 3D, put them in the game, add the weapon type the same way they've added the rest, run the game, and it'll probably fucking work. If you see,
kind of like Halo 7.
Yeah, Halo 7, BN may have broke that. If you guys ever want to see the code for Halo 7, I can show that fucking mess. It's like 1,000 line long file I banged out instantly, and it's hideous.
Yeah, I'd like to see that.
Let's boot up Halo 7, the code. Fuck me.
Oh my god.
So pretty much, if you're employed, do you have to follow, I guess, your employer's way of coding?
Yes. Okay, so one of the things people like the least out of anything ever is you showing up at the job and being like, actually, I know how to do this better.
What else is new?
They got 35 devs, they're working, they're slow as shit, and you think you can improve it? Well, unless you're hired to improve it, no one's going to listen to you. This has been my...
Which is fair.
At every job I've ever had, I come in and I'm fucking cracked usually. I live and breathe this shit. and I get frustrated. That's why I usually have tiny teams as well. Like I usually run like 2 or 3 people teams within companies. Like I'm doing that now at Tyco. Like I have 2 people under me. And I'm on top. And I came in and I did change stuff right away. I was like, no, you can see it on my GitHub because everything's open source. But you can see me just like my first 3 days at Tyco were just changing existing code to be better and more reliable. If you don't come in as a senior or a lead, I'm usually lead, never do that. You have to code how they code. And an app might be 15 years old. It might be a mess, or it might be started yesterday. It might slap. But you should usually do whatever they're doing. Unless you want to be hated. Look at this code, sound.play fart. This is shit that I was fucking doing. So this is Halo 7.
Well, 12 months ago, huh? It's been that long.
Yeah, I fucking can't believe it.
Wow.
So again, I created a function called Halo. And it takes in your image URL, which is a link, a string link, to the link to your panda after you select your panda on the main screen. Takes in your Solana address and your power-up name, which was based on which panda you picked, right? So my function Halo needs those 3 things to run. And you can see I'm doing all the same stuff we've been doing. I create a config object. So I'm using this library called Phaser. It's like a game library that comes with a bunch of built-in shit, so I don't have to write like animation code and stuff. So it wants me to make this object for them. I went to the docs and I went to the tutorials. I'm like, how do you make a game in Phaser? And it's like create a config object, and it expects these parameters on them. That's that contract we were talking about before, that model contract. Like I went to the Phaser documentation and it said make an object like this. So I did. Like this isn't magic. I literally went to the docs and it's like, okay, you need to type, and it can be of different variables. You can see if I hover over this, phaser.auto, this setting will auto detect if the browser is capable of supporting WebGL. If it is, it'll use WebGL render. If not, it'll fall back to Canvas render. So I can change that if I want it to be Canvas, phaser.canvas, but I just wanted it to be auto. The parent will be complicated for you to explain, but the width and stuff makes sense to you guys. How big is the game on the screen? Well, it's going to render it at 800 and 640. That's as big as it'll get. Like this is just stuff we've done already, and this is literal code that runs a game. You guys should be able to read this by now. Maybe not perfectly, but an object with properties and values.
No, this is helping a lot.
It's cool. I go down and I say, I'm defining variables. Let player cursors, let the move speed. This is the move speed in like I can't even remember what the fucking unit is. It's like pixels or something. Pixels per push of the key. I just banged this out, so I didn't even really read the docs. A game over Boolean, it's false, right? And game started Boolean, it's false. If I control F for game started, we can see where do I use it? Oh yeah, I've got this handle cursors function. And if the game is not started when you put cursors.space.is down, so that's another phaser thing. It gives you a cursors object, and it has a dot space, which means you've pressed the space bar. And if it's dot is down is true, then you have pushed the space bar.
Horsey.
Yep.
So when BN broke it, what did you go and fix? Like, give me an instance. You don't have to like show me, but he found a place that you didn't plan for, or what?
Yes, exactly. He did. So I had code that I gotta scroll through this fucking mess. But this is not how good code looks. But this is horrendous code. I banged it out in 45 minutes in one file. Like crane juice some.
Just think you could probably do it in 10 minutes with the AI now.
No, it's the AI is not good at specifics. That's a problem. I can't say use the phaser library and make me a game that spawns this as an interval coming from here using these assets. It's probably quicker for me to do that stuff. It's a lot better at generic stuff. I could say like, give me a phaser template for a 2D game that's 800 by 640, and it might give me like a template. But it's not good at it's not good at solving like business problems and logic yet, at like actual use cases. Or making a game funny.
How
so where is the code? There we go. Spawn cranes is a function. Okay. It shoots cranes at us, right? That's what Halo guy does. So you can see here, these cranes refer to names. Like there's two types of cranes that shoot at you. The big crane and the little crane. And I set the scale of them. It's another built-in function from Phaser. The problem is when BN broke the game, is I'll separate this out to different lines so you can see it, but this is like one function. So physics.add.sprite is a Phaser thing on the physics engine. When you want to add something, you can call .add, and then you add a .sprite function to add a sprite, like a 2D pixel thing to the game, okay? What I'm trying to do is spawn cranes randomly, and then later I set their velocity down here, velocity X and velocity Y. That's their movement on the page. They start somewhere and then they move. So when I add this sprite, where do I want to put it is what this function says. I'm adding a sprite. The third argument is the crane. That's the image I want to use. But the first two arguments are where does it spawn? And as you can tell from playing Halo 7, they spawn randomly, but it's not actually random. I had to tell it what bounds the randomness is. So here, give me a random int from interval. Int is a number, integer. So right, this function here, give me a random number between 200 and 800. And then that's the X position. And then for the Y position, give me an int between 0 and 640 and put a sprite there. And then this function runs in a loop, spawn cranes. But what BN did was I had something like this. Give me cranes spawning from 300 to 800, and then from 0 to 640, X and Y. But if we recall up here, it's 800 by 640 is the resolution. That means there is and I left this in on purpose and nobody broke it again. I'm only spawning cranes from 200 to 800 pixels wide. That means on a box, I'm starting like on this side of the screen, over here on the right where my cursor is, and they scroll randomly X and random Y. But there's still a 200 point where they don't. If I wanted to cover the whole page and spawn, they do this. Now they spawn randomly on the page, right? Everywhere between 0 and 800 on the X, everywhere between 0 and 800 on the Y, spawn a crane and make it start moving. But if I did that, they wouldn't look like they're coming from the Halo guys because the cranes would spawn behind Halo guy. So 200 is about pixels from the right of the screen is about where the Halo guys are. They're at about 150. So if I spawn them at 200 pixels from the right, it looks like the cranes spawn in front of Halo guy and like they're shooting at them. But I did it 300 before. So BN moved in that gap between Halo guy and the spawning and found out you can basically just sit in front of Halo guy.
What a legend.
Yeah.
Game was patched so I can abuse it.
Exactly.
Yeah, he did it real quick, and then BN broke it again.
Yeah, exactly. And it's still breakable. You can see the Halo guys spawn at a different thing than 200. It's still breakable. But I didn't care enough to go and be exact with it. I was like, you know what? 200 should be good. And then I pushed it up, and BN didn't break. Actually, I think he broke it 2 or 3 times, but eventually that worked. Yeah, you can see here, I add a sprite at Master Chief. That's Halo guy. I add him at 700 and 320. And then I scaled him down. And he's huge. So he takes up more room than this. So what I could actually do is, if I wanted to be perfect about it to spawn the cranes, when I'm calling function spawn cranes, pretend I'm down there again, I can say, okay, const master chief location is equal to master chief dot x. Let's call it master chief x. Now I know where he is on the page. So now I could say this needs to be capital C. Now I could say, okay, master chief dot x plus 20 or something is where I want to spawn the cranes, right? Get the actual location of Master Chief and then, Halo guy for legal reasons. And then and then spawn the cranes in front of him. But I just was like, I'm trying to make a game 45 minutes as a joke. I'll fucking try 200, then refresh the page, try 300, then refresh the page, try 150, refresh the page. That's pretty good. Okay, good enough. Moving on. Bang out this shit. But you can see the code does look like the code that we have, right? Like, I have objects like score text called .setVisible on it. And I have battle cranes text.setVisible. These are built into Phaser. Opening text.setVisible. It's not like I have a function called setVisible and it takes in a Phaser object. They're using this under the hood. They have setVisible on each object as well because they're using the dot notation. So like this code that we're doing is how code looks, right? And like within a couple weeks, you guys will be able to write a shitty game in Phaser like this because realistically, it looks like a lot. I know it looks like a lot, but you know how to do all this shit already. You just need to practice it. You know how to use dot notation. You know how to use this. Well, you're about to learn how to use this. You know how to declare functions and variables and, numbers and Booleans. And that's all we're doing. That's the whole game. That's everything this is.
Yeah.
So my question is, do we need to learn HTML after this?
Yep. Not to make games, but yeah, we are learning HTML after this. Yep.
Yeah.
HTML is the easiest fucking thing in the world compared to JavaScript.
Okay, well that's enlightening.
But the first day people start writing HTML, they will have like the basics of an app. It's so easy.
Hello world.
Yeah, exactly. Well, no, not really. Hello world's the JavaScript. Any other questions, concerns, questions about Halo guy?
No, that was cool. That helped a lot, and I appreciate it.
Cool. I will pause. Oh, there goes the dogs barking. Perfect timing. Cool. I will pause and then upload the video.
And let the dog out.
Yeah, big time. I will. I'll go deal with the dog and then I'll upload everything and write homework in a minute.